Hello, I'm Seema and welcome to part 1 of the chapter Acids, Bases and Salts. Do you know there are 118 elements? And these 118 elements, just like the alphabets in English, what do? There are 26 alphabets in English. You join them to make words, and then you join the words to make sentences, and then you join sentences to make paragraphs. And then you join paragraphs to make essays or a write-up, an article, whatever. Similarly, these 118 elements, they combine in different ways to form chemical words. And these chemical words are called compounds. And these chemical words can be made in different ways. There are different ways of combination. There is a kind of a bond between the atoms which is known as a covalent bond. There's another kind of bond which is known as an ionic bond. But we will study about all these types of bonds at a later stage. Right now, the topic of this video is acids, bases and salts. So we're going to focus on one kind of compounds, which are the ionic compounds. These ionic compounds are made up of ions, and they are made up of, and what does ion mean? Ion is a charged particle. The charged particle may be an atom which has a positive or a negative charge. When I'm talking of charge, I'm talking of electrical charges. Positive charge, negative charge. And it may be one atom or it may be a group of atoms. And they together form such compounds which have one positive charge and one negative charge, or whatever equal number of positive and negative charges. They form ionic compounds or ionic words. These compounds, they can be categorized into three main categories. They are acids, bases and salts, right? They are called acids, bases and salts. So anything which is ionic in nature and which is either an acid or it's a base or it is a salt. So how do we know what is an acid, what is a base, what is a salt? I'll just give you a brief idea about it first. As you can see, I take my food very seriously and I really love my food. That's why I have all this. I would not say I'm fat, I would say I have all the health to my side. So all these compounds are really full in me. How do you know that a substance is acidic? When you taste something and it is sour in taste, anything that tastes sour is an acid. And anything that tastes bitter is a base. B for bitter and B for base. And of course sour is sour. Anything that's sour, when you take a lemon and you put lemon juice in your mouth, what is the kind of a feel that you get inside your mouth? The sour feel. That is because it is acidic. Anything that is acidic, tamarind, you take lemon, you take oranges, you take mangoes, raw mangoes, anything that tastes sour in your mouth is an acid, and anything that tastes bitter in your mouth is a base. Well, that is only how it tastes. But that doesn't mean anything that you see acidic in the laboratory, you go there, oh, this is an acid, it must be sour and I like sour taste, and you start drinking it. You can't do that. In the laboratory, we have very strong acids and very strong bases which are highly corrosive, and even if a drop falls on you, it'll burn you, at least that portion, badly. So you have to be very careful when you're handling acids and bases in the laboratory. If we look at them chemically, what would you call an acid? What is it common? What is it in acids that makes them acidic? And what is it in the bases that makes them basic? I told you they are ionic compounds, and it is these ions, it is these ions that ionic, when we say it is these ions that make them acidic or basic. Acids are acidic because of the presence of hydrogen ion, H positive ion. The presence of H positive ion, we call it hydronium ion. Also, you will study this in later classes. But the presence of H positive ion is the one that makes a substance acidic in nature. And the presence of OH negative in a substance makes it basic. It means the acidic nature of substances is due to the positive ion of that compound. And the basic nature of a compound is basic because of the negative ion of that compound. And I told you an ionic compound has a positive part and it has a negative part. So the positive hydrogen makes substances acidic and the negative OH negative makes a substance basic. Now taking that, let us look at some examples of acids and bases. You have HCl. H is positive and Cl is negative. So in this compound, what is the positive ion? H positive. Therefore it is acidic. And we already know that hydrochloric acid is an acid. H2SO4 is hydrogen sulfate, dihydrogen sulfate actually. And it is called sulfuric acid. Why? Because what is the positive ion here? Hydrogen has positive charge and sulfate is a complex ion and it has a 2 negative charge. So the positive ion here is H positive, therefore sulfuric acid is an acid. CH3COOH. In this, it is this H which is positive. This H is not positive. You know, I told you there are covalent bonds and there are ionic bonds. In ionic bonds, the atoms have charges. But in covalent bonds, they do not have charges. So the CH3COO here, it is this oxygen which has the negative charge. The rest of it is covalent and it is this H positive which has the positive charge. Therefore, although the compound may have a covalent part to it, but it has H positive, therefore it is an acid. And which acid is this? This is acetic acid or vinegar. A dilute solution of acetic acid is vinegar. Then you have H2CO3. Again, here H, the hydrogen has 1 positive charge and carbonate ion has 2 negative charges. And therefore, since the ion H positive is present in it, it is an acid. And this is known as the carbonic acid. Bases have OH negative in them. So let us look at some examples here. Sodium hydroxide. So OH negative ion is called the hydroxide ion. So sodium is positive and OH negative is the negative ion. So whenever a compound has a negative ion and that negative ion is OH negative, that substance is a base. And bases, those bases which are soluble in water are called alkalis. So they are called bases or alkalis. Usually most of them are soluble in water. So sodium hydroxide is formed and is there, and OH negative makes it a base, and the base is called sodium hydroxide. Similarly, you have magnesium hydroxide, it has OH negative, therefore it is a base. Aluminium hydroxide, therefore that is also a base, because all of these have hydroxides in them. Then, what is this third category of compounds which are called salts? A salt is something which has a positive ion and it has a negative ion. It is an ionic compound, but the positive ion is not hydrogen and the negative ion is not OH negative. Therefore, it is neither acidic nor is it basic, but it is neutral. Such substances which are neither acidic nor basic and they are ionic in nature, they are called salts. And how are salts formed? I just took this example of sodium chloride here on purpose. Whenever an acid reacts with a base, it results in the hydrogen of the acid, which is the active, which is making it acidic, and the OH negative of the base, which is making it a base. The hydrogen and OH negative, they really love each other. So the acid and base, they join together, the H positive and OH negative joins together to form a water molecule. So what is left behind? Let us take HCl and NaOH. The H positive and OH negative joined to make water because H2O is water. So what were you left with? Sodium, Na positive, and chloride, Cl negative. These two joined together to form the compound sodium chloride salt, which is a salt. And sodium chloride is the common salt that you put in all your food. Right? So, how is a salt formed? When the hydrogen of an acid and the OH negative of a base, an acid and a base react, the H positive and OH negative are removed and they form water, then what is left behind, the positive ion and the negative ion, they join together to form the salt. Such reactions are called neutralization reactions, which we will be studying as we move on with our study of acids, bases and salts. Similarly, if you have magnesium hydroxide and it combines with sulfuric acid, the H2OH, there are two hydrogens and two that is how many hydrogens now? 2 plus 2, 4 hydrogens and 2 oxygens makes it 2 molecules of water. And what is left behind? Mg and SO4. So the salt you have is magnesium sulfate. Right? As far as writing the formulas is concerned, I'll come to that also later. How do you write down the formulae of the salts? Because that's not the topic of this video. I'll do it in a later video. Aluminum chloride. You have aluminum hydroxide and let us say it combines with hydrochloric acid. Aluminum has a 3 positive charge and chlorine has a 1 negative charge. So H2O is formed. You will need 3 hydrochloric acids to neutralize this. And the salt that you get would be AlCl3. Well, this was just a brief introduction of acids, bases and salts. If we are not supposed to taste them, as I told you, you cannot actually touch them or taste them. So how do you tell? When you look at a chemical, it's transparent, it's like water. How would you know whether it is acidic, basic or basic? Salts, of course, are neutral. So how can you tell whether a substance is acidic or basic? The way to tell whether a substance is acidic or basic without tasting it or touching it is by using certain chemicals which are called indicators. These chemicals, they show different behavior when they are put in an acid and a different behavior when they are put in a base. Now it is like, you like one person in your class is a very good friend of yours, and there's another person who you really dislike. So how is your behavior when you're with this person that you really love, who's your best friend, and how is your behavior with that person who you really dislike? Is it the same? Is your behavior the same? When you go to the person who you really like, you are happy, you are so cool, you're enjoying yourself. But when you go close to that person who you really dislike, your face starts turning red with anger and your eyes are bloodshot perhaps, and maybe you even start turning green and blue. So you start changing colors when you are in the presence of different people. So it is not just us. Chemicals, these indicators are like that, they really reveal what they are with. Their behavior with acids is different and their behavior with bases is different. So such chemicals which behave differently in acids and bases are called indicators. And indicators there are different chemicals that can be used as indicators. Some of them are naturally available in nature, so they are called natural indicators. There are some indicators which are synthetically prepared in the laboratory, so we call them synthetic indicators. And there is a third category of indicators which are called olfactory indicators. I told you that substances which change colors, maybe they start smelling different. Olfactory nerve is a nerve in which gives you the sense of smell. So olfactory indicators are those that give you a different sense of smell. Substances which start smelling differently in acidic and basic medium, and therefore their smell reveals whether the substance is acidic or is it basic. So I told you that indicators are mainly of 3 types: natural indicators, synthetic indicators and olfactory indicators. What is the job of these indicators? They only tell you whether the substance that you are testing with them is an acid or is it a base. They do not tell you how strong is an acid or how weak is an acid, or how strong is a base or how weak is a base. They do not tell you about the strength of an acid or a base. Do you remember when I told you that when we eat something which is sour, it is acidic in nature? So if we are eating it and it is not corroding, it is not burning our skin, it means it's a weak acid. If there's something bitter that we are eating, if we can put it in our mouth, it means it must be a very weak base. While taking a bath, has the soap ever entered your mouth as a kid? And have you ever tasted the soap? It's kind of bitter. That's because soap is basic too. It just came to my mind. So I was telling you that these indicators only indicate whether the substance is acidic or basic. It doesn't tell us how strong or how weak the acid or base is. For that, we have special indicators which are known as there is a scale that we use which is known as the pH scale, and the indicator we use is known as the universal indicator. Now these are a little complex indicators. You need to understand more about it to know these indicators. They not only tell you that the solution is acidic or basic, they also tell you how strong the acid or base is. So we will do the pH and universal indicator in a later video. Right now I'm going to talk about these simple indicators which only indicate acidic or basic nature of a substance. So as I told you, we're going to start with these indicators. I made a table here. I have how many? 11 indicators that I've marked out, and out of these the first 9 are the ones that you have to memorize. And these are just added for your information. Maybe you would enjoy knowing it. And I've tried to include all kinds. Now, among the natural indicators are litmus, turmeric, onion, clove oil, hydrangea, red cabbage. All these are natural indicators. Synthetic indicators are methyl orange, phenolphthalein. Even the pH and universal indicators are synthetically prepared, but since we are talking of simple indicators, we'll just talk of these now. Olfactory indicators are natural indicators too, like onion, clove oil, and vanilla extract. Vanilla extract can be added here too. So now that you know what categories of indicators these are, let us now see what is the behavior of each indicator in acidic and basic medium. The first is litmus. Litmus is a solution, and it is prepared, or it is we sometimes have paper, which has been dipped in litmus solution, and those strips are dried and they are given to you in the laboratory. So you will get litmus either in the form of a solution in the lab, or you will get it in the form of paper strips. So the color of litmus solution, basically litmus is, if it is in neutral medium, it is purple in color. But if you put it in acids, blue, it turns red. The purple litmus, it turns red. And usually, it is one of the two colors, blue or red. The purple must be the original color of the pigment. And this pigment has been obtained from lichens, an organism, a plant from the Thallophyta family. It is obtained from the lichens. And this pigment, it turns red in acids and it turns blue in a base. So how do you memorize this? RED, the last letter of red and acid are the same. So we say litmus turns blue litmus turns red in acid, and red litmus turns blue in base. B and B match with each other. D and D match with each other. So in order to memorize, this helps you to memorize that blue litmus turns red in acids and red litmus turns blue in base. The next indicator is turmeric. Turmeric, we use it in cooking to make curries. Turmeric is yellow in color. Have you noticed sometimes when curry falls on your dress and you put it in the, when you're hand washing that particular area and you put a little soap over it, it turns brown. So what is happening? Turmeric, what did I tell you? The taste of soap is bitter. So when the taste of, it means it is basic. So what happens in base? Turmeric is yellow in color. If you have acidic solution, it remains yellow. But if you put it in a base, it turns brown. The color of turmeric turns brown. So turmeric is also a natural indicator. Next is onion. Onion is an olfactory indicator. It has a characteristic smell. When you chop onions, that characteristic smell that comes in the entire house. So onion, it has a distinct onion smell. If you put it in an acid, you can still smell the onion. But if you put it in a base, that smell is lost. Let me tell you one thing about all the olfactory indicators, the ones that we are going to study. Onion, clove oil, vanilla extract, all the indicators, they still retain their smell when they are in acids. But if you put them in bases, they lose that smell. You can no longer smell them. So if the smell of something irritates you, add a little base to it. Something which is tolerable for you, but if you add a little base, that smell will go away. So onion has a smell, in acid it has a smell, but in base it has no smell. Clove oil is also an olfactory indicator. It has a smell of its own. You've seen clove oil. It has a distinct smell. You use it the dentist uses it for your tooth. Then in acids, it has its own smell, but in basic solution, the smell is lost. Clove oil is done. Vanilla extract again is a sweet smelling. You have vanilla ice creams, it has the vanilla extract in it. So vanilla extract is a sweet smell, and you will get the smell in acid, but if you put it in a base, it'll not smell. Hydrangea is a flower, and hydrangea flowers are blue in color. I have this hydrangea here. So hydrangeas are blue in color due to the presence of a pigment. And it is these blue, the actual hydrangea, if it is a neutral solution, is purple in color. But if you put it in acidic soil, if you put acid in the soil, it turns pink. But if the soil is basic, the hydrangea flowers or the blooms that you get are blue in color. So hydrangea is also a kind of a natural indicator. Red cabbage, you eat the red cabbage. If you just grate the red cabbage and take out the red pigment out of it, it is red in color, of course, but if you put it in acid solution, it remains red. But if you put it in a base, it turns green. It turns green in a base. So red cabbage is also a natural indicator. Methyl orange is a synthetic indicator. You remember methyl orange, I put it here. Methyl orange is a synthetic indicator. It is a compound that is prepared synthetically, and as the name suggests, methyl orange. Its original color is orange when it is neutral. But when you put it in an acid, it turns red, and when you put it in a base, it turns yellow. And the ninth indicator is phenolphthalein. It is one of my favorite indicators. I don't know why. It is such a beautiful, colorless solution. It looks like water, and if you put it in an acid, nothing happens, you don't see. But if you put just one drop of phenolphthalein in a base, or you take phenolphthalein solution in a test tube and put just one drop of base in the phenolphthalein, it turns pink, and it turns a beautiful pink. And the stronger the base, the stronger is the color of the pink that you get. So it's a beautiful, I think this is one of the most beautiful reactions that you would see in the laboratory. The color of phenolphthalein turning pink. Then you have petunia petals. Petunia is a flower, and the petals of petunia, they may be different colors, of petunia petals. But if you put it in an acid, you see that it turns reddish purple. And if you put it in a base, the petunia petals, you crush them, take out the pigment and put it in a base, it turns violet in color. And then you have blackberries and blackcurrants. These, are black in color, they appear to be, and you just crush them, get out the pigment. And you put it in an acid, it'll appear red. But if you put it in a base, you'll get a blue color. So these are the different indicators and the different colors that you see in acidic and basic solution. I would suggest you pause the video here and copy down the table and try to memorize it till 9. The most important out of these, if you really see, if I had to pinpoint which are the most important indicators, I would say litmus is the most important. Then you have methyl orange and phenolphthalein, because they are chemicals that you would be using in the laboratory. In chemistry, although all the natural indicators, they are there, but at home maybe you may be using them more. You won't be using them as much in the laboratory. So for your study of chemistry, I guess these three are the most important, but till 9 you must learn them. So pause the video, write it down and learn, or get a screenshot of it and learn this table at least up till 9. So, and after that I told you there is pH, scale and the universal indicator, which we'll be doing in a later video. So if you found this video helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.